Hello, this video will be about the Great Pyramid, and so recent video series I've done on modern architecture, but I believe that all of it points back to some very important pieces of ancient architecture, such as the Great Pyramid, but not exclusive to this. Uh, at the time and for 4,000 years, it was the tallest building, probably still is, if not the most, but one of the most remarkable structures ever made, and it was made at the beginning of time by people who supposedly had no experience, no libraries, nothing to draw upon, and yet they created not only a perfect structure in terms of its construction, but also in terms of its proportions and all the measurements and the relationships that they have to some very important mathematical uh, stuff that's basically the fundamentals of nature, the fundamentals of modern maths, and supposedly it's not was not invented until thousands of years later. And again, through measurement and examination of it, I believe you can draw on this, and it basically uh, the measurements, etc., are undebunkable. Some people just simply refuse to accept this because of the worldview paradigm. But the Great Pyramid, it's one of the it's still one of the most enigmatic structures. The weight, the size, everything connects. Now, um, most people examining this will use the ideal proportions, and by that, for instance, they that the Great Pyramid has the proportions of pi. Traditionally, though, most references will have half pi, but that's because you're examining it as a 2D object, and I think that's one of the big mistakes that's been made with so many people examining this, because the Great Pyramid is a three-dimensional object. And for instance, if you look at it from the corner using the ideal measures, where each base length is 440 by 440 Egyptian royal cubits and 280 high, well, instead of half pi, what by looking at it from the corner as a three-dimensional object, what it is, not a piece of paper, but a structure in itself, you stand at the corner, what you can see, maximum visible base length, which is a key thing in regards to pyramids or three-dimensional objects, is that from perspective, the proportions change, but the most you can see from ground level, so as you're walking around, the most you'll ever see is 880 Egyptian royal cubits, and 280, which gives us 22/7, which is as good as a example of pi that in the practical sense that you can use. However, it does get more and more perfect, and I'll put links to the descriptions because I've done some videos on this before. But just to point out, these are the ideal measures, and this in itself is a wonderful thing. However, the Great Pyramid is not exactly 440 cubits by 440 cubits on each side. It changes slightly, but it does have these proportions of pi. Yet it also has these a proportion, well, several proportions pointing towards the golden ratio, or phi, and once again, using the ideal proportions of 440 base over 280, you'll get this, which is 1.6181818, which is excellent in regards to Fibonacci numbers, golden spiral, but it is not the exact value of phi as described by Pentagon. And again, this is all based around the ideal measures. However, the pyramid itself, there's been some survey done in before, but even modern survey. And for instance, this is the J.H. Cole survey, which also includes the Egyptian government survey. And what you find is that each side has a slight variation, and these measures have been backed up. So the pyramid is not exactly the same on all sides, and that might be conveniently dismissed as an error in construction. I don't believe that's the case. I believe that the supposed margins of error are actually pointing to something much more profound, and which not only reinforces the pi and phi ratio amongst all these other points, but it also points to a perfection in these ratios, and that it needs to be viewed in this sense as a three-dimensional object. Each corner, each side, each face has a specific meaning, and by that, and so here we are. Pardon. Okay, so there we are. Here's the Great Pyramid. And you can see, like, I've made it a bit transparent so you can see the internal structures. Again, the official explanation about the eight-sided pyramid would say it was an internal collapse, yet all the structures remained intact. They've been intact since it was built, and it's just yeah, the official story of the eight-sided pyramid being a collapsing on each side at 90 degrees from another is patently ridiculous. No one in their right mind should be selling it. No one should be believing it. But what I have here is also a diagram, and here's my theory that each side of a pyramid, each corner in itself has its own particular meaning. And I'll put the links to the longer video where I go into a little bit more. But for instance, here on the southeast corner, what we have is pi and phi squared in perfect proportions. Along this axis we have phi in perfect proportion. The northeast corner represents astronomy, and not only that, the time and the second, and the second comes from the 1 meter pendulum. The north axis represents phi squared, perfect proportions, but also points us to the proportions of the Earth and the Moon in relation to one another. So what I'm saying is that the northeast corner, okay, and before I go on, so the southwest corner, this also has pi and phi squared in beautiful, perfect description in meters. The meter, the cubit, and the second are all linked together. The 1 meter pendulum, that section of arc is exactly 1 Egyptian royal cubit, which is pi over 6 meters. And again, I'll put links to the longer videos, but I want to just doing a quickie to show one aspect of it. And what I mean by that is now we're going to look at this corner, the northwest corner, and it represents geometry. Not only geometry, it represents geometry in the second and the third dimension. And so if we swivel around, what I mean by that is, so what we have is this, so on the eastern axis, what we have is a proportion which is 1.273236, blah, 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 which again is in a head, now with including the margins of error in all these descriptions, including the slight indentation because of the eight-sided pyramid. This actually comes much closer, but just as an illustration, that number 1.2732 is the ratio of area from a circle inside a square, essentially 4 over pi, well exactly 4 over pi. A circle and a square, that's a two-dimensional ratio of area. And again, this is very important in geometric terms. It's not some fluffy information. It's so important to our modern world. And that is a two-dimensional description of the circle and the square, which is another reference into regards to the Great Pyramid. So that's on the axis, which is a two-dimensional representation. However, if we zoom out, and so from the peak to the corner and the half base there, so the green and the light blue there, including the socle, which is again is another important reference. We need to look at the pyramid as a three-dimensional complete object to see. Well, we get the ratio, and again, because of a millimeter margin of error in the survey will result in a slight change, but what essentially we have is a ratio of 0.23555519 based on the J.H. Cole survey. If again we're splitting hairs in regards to this, but why is that important? Well, because a sphere inside a cube has a ratio of volume of pi over 6. Pi over 6 meters equals 1 Egyptian royal cubit as defined by the Great Pyramid. It also describes the ratio of volume of a sphere inside a cube. Three-dimensional. Over here we have so a two-dimensional circle, a three-dimensional sphere, a two-dimensional square, a three-dimensional cube, 2D and 3D. This is using this method. The beauty of the existing research that's been done into this only gets better and better and better. And I think it's there to be tested, it's there to be measured. It's not there to be argued. Unfortunately, there's some built-in resistance to some of these things because things get rusted on. But here's what I'm saying, here's what I have, here's the measures. You can use a JH Cole survey, you can use even more modern surveys to find this. If you include the slight indentation because of the 8 sides of the pyramid, it actually gets closer to perfection, and it is so, and the margin of error is so small as to be effectively negligible. And well, here's another point. This is what the Great Pyramid is pointing us to. It's one of the most perfect buildings. It's overloaded with information, and the so-called errors in construction, the so-called margins of error in measurement, actually point us to something much more profound, much more beautiful. And there's the information for you there. Unfortunately, I'm not one of the recognized sort of people, so therefore it doesn't get taken into account. And yeah, anyway, so the Great Pyramid, each corner represents something very important, and so it's not only about perfect proportions, it's about perfect measurements, it's about perfect geometry, and it's also about some wonderful astronomy. And the meter, the cubit, and the second are all connected, and even that brings us the so-called modern foot is actually based on this as well, and is wonderful mathematics, but it's all just because it just breaks the existing worldview, or it confronts the official alternative views of this. That sort of it gets overlooked or photocopied. But either way, I'm here to enlighten, not to fatten my wallet. This is a system. This is a measure. Study, study, study. Math number is the language of the universe. It is eternal. It cannot be lost in translation. It is a universal, fundamental, the core of all language, of all knowledge. And there it is. It's there to be tested. It's there to be measured. Phi, pi, so many other points I'll put. Yeah, the links will be in description, because there are using ideal measures, using the 4-3-2 scale, I think is a big mistake, because it's we need to be as accurate as we can, and the more accuracy involved, the more knowledge there is to be extracted. Looking at it as a 3-dimensional object, which it is. It's 3-dimensional. It's a pyramid. It's not a triangle. It's a pyramid. And with that, I hope you enjoyed, and have a good one. Again, links in description.